Thank you everybody for joining today. I'd like to give a shout out to the folks in Apply for hosting the Druid Summit and allowing me to speak today. Today I'm going to be talking about how Amobee leverages Druid in the reporting pipeline to further enhance their data scale and move away from multi-level aggregates. All right. So let me start by introducing myself. My name is Kevin Pang. I currently reside in Austin, Texas. I was able to move here before the pandemic and before Elon Musk. So I was able to get in before the housing prices kind of went through the roof. I've had over 10 plus years in the data realm. I've worked at a few other companies before joining Amobee. The most notable one or the recognizable one would be PayPal. And during my free time, I like to scuba dive. I've done a lot of dives. One of my most memorable dives was diving off the shore of the Socorro Islands, which is basically a rock in the middle of the Pacific. I saw like manta rays, sharks, dolphins, tunas. It was crazy. So if you're a scuba diver, I highly recommend that you put that on your bucket list. I love Kung Fu, so currently practicing Kung Fu. Before I moved to Austin, Texas, I was actually in Los Angeles, and there I'd do a lot of dance classes and was a big fan of hip hop dance classes. And then I guess the most important thing about me is that I'm an avid Druid fanboy. Okay, so let's talk about how Amobee used multi-level aggregates in kind of our legacy reporting system. So let me start off with kind of what multi-level aggregates are and kind of what it means to Amobee. So Amobee is an ad tech company. We deal with advertising in the social realm, the display realm, the TV realm, so on and so forth. So we get a lot of data. I'd say like terabytes of data a day on everything dealing with ads. So if a user kind of or an entity sees an ad, we get an event triggered and we see that data. We see like there's an impression recorded for this ad with these attributes, for this entity with these attributes associated with them. So we get these terabytes of data. At the time we stored everything in a transactional database. We were kind of using a cluster of MySQL databases. But for reporting needs, the customer does not need to know the data at that fine level. They kind of care more about like, hey, I have this campaign. What are my number of impressions for the last 7 days? How well is it doing based on that? So if you imagine like looking at your transactional database and you're querying like terabytes of data for and kind of aggregating for 7 days, it can take a long time. So kind of a tool set that's used is to kind of keep different aggregation levels stored. So what we could do is we can basically roll up the data at, let's say, the week level or the month level. So we can have a data set that's the last 7 days, the last 30 days, the last 90 days, the last 365 days. That way, when the customer asks, hey, I want to know what my numbers are for the last 7 days, instead of kind of doing this roll up on the fly when they're asking for it, we just do a simple select query off the table that has a 7-day record that's already pre-aggregated. So what does Amobee use these multi-level aggregates for? So at Amobee, we have kind of certain SLA requirements for us. We do feed the user interface with our reporting pipeline. So it was very important for us to make sure that the queries have a low latencies, and that's kind of why we use multi-level aggregates when we were using our transactional databases. We also deliver data to internal teams which have their internal SLAs to therefore display to the customer or feed to the customer. And we do have a use case where the SLA is not as stringent, which is to kind of deliver basically our offline reports to customers. So I kind of touched a little bit about this on how multi-level aggregates speed up reporting. Basically, you're condensing the data size, right? So you're rolling up the data. So instead of keeping all the data at the event level, the millisecond, the second level, you're rolling it up to the level that you need, right? So I know I need a report that's at a week level, I need a report at the month level. So I'm just going to roll up that data, store a table that has it at the week level, at the month level, and so on and so forth. A trick that we used at Amobee was that we got to keep in mind that transactional databases store their kind of data row by row, right? So it's very, it can be very expensive to kind of do calculations that are some linear combinations of the columns that you have. So the trick that we used at Amobee was we kind of pre-computed some of these calculations that we knew the customer needed ahead of time. So we would actually create another column that had this calculation stored in it. This then further simplifies everything to become just a simple select statement for the use case for that report that the customer needs. Basically, we did everything we knew ahead of time so that the speed is optimized for pulling the report for the customer. So now we run into a couple of trade-offs here with multi-level aggregates here. The main one that we ran into a lot, time and time again, is data duplication, right? So we have all this data. It's stored at, we already have it stored at the, the event time level, right? We have it stored at the lowest granularity, which is the seconds, milliseconds, right? But we have a need to store it at the week level because the customers need it quickly. So we have a copy of the same data at the week level. I mean, it's rolled up, but it's still there at the week level. We need it at the month level, the quarter level. We're keeping a copy of that. Keeping a copy of that, it adds to the storage cost. But on top of that, you need to kind of keep in mind which aggregate levels you have copies of, right? So it just adds a little bit of complexity to the system. Now, what are some of the trade-offs we have with multi-level aggregates? It kind of forces everything into kind of a predefined pattern for retrieving data, right? One of the tricks that we did in Amobee to kind of save on storage costs was that we kind of knew ahead of time, like for certain reports, it didn't really need all those columns. So when we create those aggregates, we might have not have exposed those columns to save space. So now you run into this problem of well, now the customer says for this report they need those columns, it becomes unflexible, right? The other kind of issue that we run into is, for our data, most of the times we're time bound, right? The customer asks for the last 7 days, the last 30 days, the last quarter, so on and so forth. How do you deal with time zone, right? One way is to, when you roll it up, you have one for Pacific time zone, for Eastern time zone, so on and so forth. But you run into that issue of okay, now I have, exploded my data duplication even more, right? Another option you could have done is for each row at the week level, you keep it at the customer's time zone, but then you kind of lose that flexibility. If you have a customer that has multiple time zone region and they kind of literally want the report, one manager wants to report at Pacific time zone and another wants at the Eastern time zone, you get into this inflexibility kind of problem. Not to mention that we're bucketing it to 7 days, 30 days, so on and so forth. So if they want a custom range, it kind of becomes a little bit more difficult to manage. So the last kind of big trade-off that we here at Amobee had encountered with multi-level aggregates is just maintenance, right? The pipelines to build them, they become very convoluted, right? You have, you may have a trunk for one kind of data set, but then within the trunk you have all these branches, right? For aggregation 1, aggregation 2, aggregation 3, aggregation 4, so on and so forth. So it's a lot to keep in mind, a lot to manage. On top of that, at Amobee, we kind of use we use a shared Hadoop cluster to kind of run all our processing, right? So we have all these MapReduce jobs, fighting for resource yarn pools. So we have to worry about what happens if another team steals our resources and their job gets running and it kind of delays our job, right? Or what happens the opposite way? What happens if we have a rogue job for some reason monopolizing the cluster? It just makes life a little bit difficult here, trying to trade off with these resources. The other kind of thing that we need to note is that we try to as a result of trying to minimize resource utilization or trying to kind of be nice with it, we kind of scheduled our jobs to run at periodic intervals. And this caused an issue with I'd say like one of the main issues that we occurred was that we had a use case for a report to be delivered to the customer for yesterday's data at their 9 o'clock in the morning, right? But the problem is that we could only, due to the resource constraint, we could only run it at a certain time, and that time was at Pacific time at like 6 o'clock in the morning. So what happened is the customers that were in the Pacific time zone, they were happy. They got the reports on time. But the customers at the Eastern time zone, they got it during lunchtime. And don't even talk about customers in Asia. They when they got those reports that they needed to act on, it was just too late, right? And then due to the resource constraints as well, if, like I said, a job monopolizes something, it could delay our jobs and can delay our pipeline from completing, which further delay the results to the customer. And then the last kind of issue I want to touch upon with these pipelines is that let's say you have a trunk for a data set and you're having all these different aggregations kind of flowing from it. They're not all guaranteed to finish at the same time. So you might run into an issue, which at Amobee run into a few times, is that let's say a customer pulls out 4 weekly reports, right? And then they pull out a monthly report, a 30-day report. There is a possibility that those numbers won't match because they could have pulled out the weekly reports when it finished ingesting into our system, but it hadn't finished ingesting the monthly data into your system. So you have this mismatch. You have this race condition that you have to manage, and it causes the customer kind of like not trust your data, right? And you try to minimize it as much as possible, but it's always going to be there. So let me start talking about Druid and how Druid kind of came into the Amobee reporting ecosystem. Okay, so we didn't at Amobee, we didn't discover Druid right off the bat, right? So we actually have a team that manages our data lake, and they use Spark, the Spark framework on top of Parquet files the entire time. So we initially tried to kind of do a POC on that and see if it can handle our use cases. Unfortunately, it didn't. We actually have use cases where we need to run like 200 to 500 reports and have them all finished within an hour. When we tried to do this use case in Spark, we were only able to get to 5 reports finished within an hour, which is far off our use case. We tried Presto as well. It also fell into the same boat. Eventually, we did find Druid. And when we did our POCs, we noticed like it had really fast performance. I remember we had a specific use case and we got a query response back within like 250 to 300 milliseconds, which is blazingly fast. It was easy to scale. So as we were doing our research, we noticed like, if we need more data volume, we can either expand the historical nodes, we increase the hard disk space. If we needed to scale up the number of parallel processing, easy to do. Look at the brokers, look at expanding the brokers, and so on and so forth. So scaling is straightforward. The other thing that I liked about Druid, as I discovered, was the community. It's very active. At the time, we were starting our POC on version 0.16, so the Druid forum wasn't there yet, but I noticed that they had a Slack group. And when I joined the Slack group and I asked questions, I noticed like my questions were getting answered, some within an hour, but definitely within 24 hours. So it's a very active community, very supportive, and I really appreciated that. And then next, I'm going to talk about the key benefits that Amobee saw when we adopted Druid into our reporting pipeline. So one of the benefits that we saw, and kind of was a con of the multi-level aggregates, was we only needed to keep 1 copy of data right now. We just needed to keep it at the lowest level that would suit our use case, the lowest granularity. And for reporting, that's at the hour level. So we could just roll up data at the hour level, and given data rolled up at the hour level, we can support reporting at any time zone, right? Whether it be week, month, quarter, so on and so forth. It's just 1 copy of the data. Another benefit that we got was that it just severely simplified our pipeline, right? Our data pipeline, we no longer have this trunk with all these branches off. It just It's just one trunk, right? I'll talk about it a little bit later down the slides, but we no longer actually have to do any pre-computed columns or any of these data aggregations that are done to produce these aggregates anymore. We just have that one pipeline from Druid into Druid for our data set rolled up at an hour, and that basically serves our needs. So another benefit that we kind of got into was that since we no longer have to keep these data pipelines around, these multiple level aggregate pipelines around, it led to decreased resource utilization in the Hadoop cluster, right? We actually started giving back some of our Yarn resource pools to other teams. And then, pulling out of this, we don't have to worry about these resource hog jobs anymore. We don't have to worry about us being a resource hog job. Now, there's a caveat. The caveat being that we, as long as we kind of use the index parallel and use Druid native ingestion, we get away from our Hadoop cluster. Druid is flexible enough to allow you to use Hadoop resource and use MapReduce jobs to ingest into Druid, but I suggest that if you want to decrease your footprint in Hadoop, just try to stick to the native Druid ingestions as much as possible. So a lot of these benefits that we gain is because Druid is pretty quick at aggregating and calculating on the fly, right? We don't have to pre-compute the columns anymore because you can actually get them computed during query time quick enough to satisfy our needs, right? Another thing that we got, a benefit from Druid that we got was that Druid actually supports these approximation algorithms. We have a couple of cases where we need to do select distinct counts, and we don't really care about the exact answer. Like getting close enough is good enough, and Druid supports that and is able to give us an answer pretty quickly. So a lot of the gains that we get from moving away from multi-level aggregates is because the querying engine or the querying part of Druid is just really quick and able to kind of do everything on the fly. Now, all these benefits just basically leads up to cost savings for the company and more potential earnings being made available, right? You no longer have to keep these complicated data pipelines, so you reduce costs on dev maintenance and kind of worried about it. Now that everything is done during the query time, you don't have to worry about like exposing new calculations in like the data pipelines anymore. It can just be easily exposed at query time. And then on top of that, you have this decreased resource utilization on the Hadoop cluster. So we get away from that. And all this basically leads to all the cost savings that we get, plus quicker time to market due to the fact that it's easy to kind of turn around these calculations. So now I'm going to talk about how, I'm basically going to talk about the reporting ecosystem that we use and kind of how Druid fits into this entire tech stack. So for our the beginning of our tech stack, we actually use Apache Airflow. We use it for our workflow orchestration. We basically have predefined schedules for when we're pulling certain data from the data store and ingesting into Druid. So it handles that. We do have the need for ingesting into Druid as soon as data appears. So we have Airflow has this kind of API that other teams can call when data is made available. So we allowed other teams to kind of basically trigger our ingestion process by using Apache Airflow. Now, in lines with allowing other teams to kind of trigger ingestion to Druid here, we kind of have an additional like validation that we kind of put in Apache Airflow to kind of make sure that the data that's coming into Druid kind of conforms to what we expect, right? We want to make sure that the schema that they're sending to us matches the data that they're actually giving to us. We've run into a couple of cases where they would say, hey, this data I have has 10 columns, and then we would look at it and it's actually 4 columns. So and on top of that, we use it to abstract a lot of the feature sets that Apache Druid offers through its ingestion spec, right? Our internal teams, they don't really need all that. They don't want to worry about that. They just want to say, hey, here's the schema. I know it's for this time range. Just go, right? So we use it to abstract all those specifics as well, just to make it easier for our internal teams not to have to know the specifics of Apache Druid. Now there is some pre-processing that Druid we cannot get that Druid doesn't support, right? It does support a lot of pre-processing. The transformation spec and the ingestion spec is amazing. We used it recently to kind of look at filtering data that we didn't want in our tables, and it works beautifully. It's great. But the use case that we have where Apache Druid doesn't natively kind of take the data is that we have a use case where we process data and ingest data from our data lake at a predefined interval. But the data in the data lake is stored in a more normalized fashion than we would like. So for our use cases, we want the data to be as denormalized as possible. So what we did was we kind of create a denormalized view on the data sets that we need, and we had Apache Airflow just basically materialize those files for us. So that's something that is not really supported by Druid. It's kind of, I would say it's kind of specific to Amobee's use case. But after we kind of materialize those files, everything else kind of just gets processed in Druid. And of course, like I said, it just creates the ingestion spec with all the parameters and just submits it into Druid for us. Now, let me talk about Apache Druid. I would say it's the backbone of our reporting system. It's our data store. It's used to ingest data into our system. For the most case, Druid in the ingestion spec has the option of specifying whether you want to roll up the data or not. For us, we're always rolling up the data, right? For our reporting use cases, like I said, we don't really need to look at data at the event level. We need it to look at it at the, let's say, an hour level or something. So we have data natively kind of just roll up that data for us to the hour level, and it does it perfectly. It also gives us the option to kind of like say, hey, we're going to need to kind of use an approximate function on this. So it kind of gives us the option to say, hey, by the way, this is kind of, we're going to be doing some approximate calculations in query time. Please speed up this field, right? Like I said, we also, use it to specify some transformations to the data as well, where it makes sense, like filtering out data. Okay, so for querying, for the most part, for querying into Druid, we kind of won't learn that out. We don't want our customers to kind of just, have a carte blanche at querying Druid. We kind of want to make sure that we silo out like, specific use cases so that we meet our stringent SLAs, right? We don't want to have a rogue query going in and kind of taking over everything, right? There is one exception that we had recently is that we're investing in the Looker tool. It's a kind of BI tool that allows you to kind of do BI visualizations. And it actually hooks directly into Apache Druid. So it's very easy to kind of hook in. What's great about it is you can still do some wall guarding in it as you create certain, like, I think they call it explorers. You can kind of specify how a user interacts with it. So you can kind of still wall guard it a little bit in there. So the last kind of tech piece in our pipeline is we have this Spring Boot application that we built on top of Kubernetes. And what it does is it's just responsible for serving data to the customer. So our customers, they don't necessarily know SQL, or they don't really know like the native Druid queries. Literally all they're saying is, hey, I want data that is pertaining to these columns or these fields, and I want it aggregated at the week level or this date range. It just basically takes a simplified request from the customer and just translate it to a query and submits it to Druid, right? It does do some validation. It makes sure that the request that the user asking for makes sense before submitting to Druid. What's interesting is that this validation helped us kind of discover a white hat that went into our system. I think Amobee periodically, they kind of hire white hats to kind of see if they can kind of take over our system. But the validation system here kind of helped us get it so that it didn't get submitted to Druid. The other thing it does is it deals with load balancing. So load balancing with brokers, right? So we initially tried to use HA proxy to kind of load balance it, but we ran into an issue where like it actually ended up killing our SLAs. So we kind of built in load balancing into our Spring Boot application. We actually segregate our brokers into two sets, right? We have a set of brokers that deal with requests that require like second SLAs, like 1, 2 second SLAs. And we have another set of brokers that it's okay if it takes a couple minutes, right? So the Spring Boot application is responsible for understanding the request and kind of directing it to the right set of brokers. Once directed to the right set of brokers, it just does a simple round robin and kind of issues the request that way. So, I mean, that's all I have for my presentation today. We've been with the, we started with Apache Druid on version 0.16. We're currently on 0.211. We've been with it for like 1.5 to 2 years, and so we look forward to seeing what else Druid has to bring in the future. But yeah, that's it for my presentation. You can reach out to me at this email address. I'm also somewhat active on the Druid Slack. So if you're in the Druid Slack, there you can kind of find me and ping me there. But I think we do have some time for questions. So if you have any questions, please feel free to ask.
Hi, Kevin. Thank you for such a wonderful presentation. We have a question here from
I'm sorry, you completely chopped out, Zeke. I didn't hear what you said. Zeke, did you hear me? Oh, let me see. Let me go to the Q. Oh, okay, sorry. I'm going to the QA section. Sorry. How do you store and later access the pre-computed results? So Cole, I think you're talking about when we're using the transactional databases, right? So what we did for multi-level aggregates, what we did was we knew, we knew that like the report required some linear combination of column A, B, and C, right? So what we do is we would, in our MapReduce processing pipeline, as we're ingesting and rolling up the data, we actually do those computation and store it in another column, like column D. And then when the user requests for it and they're saying, hey, I want this calculation, we don't do the calculation. We just say, hey, here's the result, column D. So that's kind of how we did it. I hope that answers your question, Cole. Any other questions? Yes, everything was, Cole, yes, that's correct. Everything was computed upstream. And the beauty of Druid is the fact that we don't have to do that anymore, right? It can be done during query time, and we don't have to worry about it. And like I said, it's because we were using transactional databases, specifically MySQL, and it's not like the data is stored in per row, right? So it's not like a columnar store where you can just take the 2 columns and just do the calculations. You'd have to literally filter the rows, then index into the column and do the calculation. So it's based on the data size you have. It would be really slow. Cool. Good question.
Yeah.
So actually, sorry. Cool. Yeah. So that's a good question here. For switching over to approximate aggregation in Druid, it's actually pretty simple. In the ingestion spec, you can specify like, hey, this column I need to prime it for using like HLL or I forget what other data sketches or whatever, right? You just say, hey, this is a sketch column. I want to make a sketch column based on this, right? Once you create the sketch column based on that, what you do is that there's a special function on querying in Druid where it's like HLL distinct count or data sketch distinct count, and you specify that column, and that's it. it's kind of pretty simple. The other thing I forgot to mention that's very interesting for people that are using transactional database, especially with time, is that a lot of time we run into this time zone conversion where like I don't know, daylight saving time and all that stuff. Actually, it's pretty easy in Druid. You can actually specify. So for us, we store data at GMT in Druid, right? So it's pretty easy for us to specify like, hey, we want that data returned back in PST, because Druid has this Druid query context where you can literally say, hey, I want it back in this time zone, and Druid actually automatically takes care of it for us, including daylight saving time. Everything is taken care of for us. Like, I remember when we work on transactional basis, like it would always be like daylight saving time is be the day that we'd be like, oh my god, okay, let's make sure everything's okay. So I know it just passed by, so that stuff is no longer a concern with us from our reporting pipeline due to all these feature sets that Druid has for us. Cool. Is there any other questions?
No, I think that's all the questions. Thank you so much for a phenomenal presentation.
Thank you very much for having me.